Hello and welcome to the pre-conference podcast for the Summit on Energy Efficiency for the Life Science Industry. That's going to take place in Berlin on the 3rd and 4th of November. Today, we have the pleasure of introducing you Luca Brotto with Karel. Luca, thank you very much for joining us today. To start off, could you please tell us about your role in the company and a small introduction about the company itself?
Yeah, sure. Hello, Dmitry. It's our pleasure to be here today. I am Luca Brotto and I work as application manager inside Karel. My role is within the industrial marketing unit, and in the previous years I've been working in the sales department and in the technical sales for HVAC controls and humidification systems. Karel is a company producing, manufacturing controllers for HVAC, so air conditioning and refrigeration. And with the aim of leading the innovation of control technology for humidification and air conditioning and refrigeration, supported by products and services for our customers to reach the highest efficiency and sustainability in the market.
Thank you very much for this introduction, Luca. When speaking about energy efficiency, it had a close focus in the life science companies as well as other industries. Why is it important to control and monitor air conditioning systems in life science facilities?
Well, controlling and monitoring air conditioning systems is crucial for life science facilities because the quality of the final product and the safety of the personnel working in the plant are strictly related to the air treatment. Concentration of contaminants, presence of dust, stability of temperature, and a correct level of relative humidity can be ensured only with an integrated approach. When an operator enters a clean room, the consequent change in air pressure requires a prompt action from the ventilation system that must be able to keep or to rapidly take back the environment to the desired set point. High efficiency systems can modulate the required airflow instead of working at 100% capacity all the time, thanks to carefully designed algorithm and responsive components. The efficacy of such systems is proven and can be fine-tuned thanks to monitoring systems able to provide insight on the process quality.
Thank you very much, Luca, for sharing that. Now, diving deeper into more technical topics, what are the HVAC solutions impacting on energy saving and carbon footprint reduction?
Thanks for asking. Integrated control of heating, cooling, and ventilation in a system is the key for energy saving. In fact, the use of variable speed technologies, heat recovery, adiabatic humidification, and evaporative cooling need a really deep comprehension of how one influences the other in order to get to the desired result, which is saving energy and reducing emissions. Recovery of heat and revamp of existing units with high efficiency components and controls play a big role in making today's energy saving and carbon footprint reduction challenges for industry one step closer to target.
Oh, okay. And why should relative humidity level be controlled inside clean rooms?
Inside clean rooms, and more in general inside life science facilities, we have people working 8 hours per day, maybe on 3 shifts per day. Scientific studies demonstrate that a minimum level of humidity around 30% inside working environments reduces the spread of airborne particles and improves efficiency of immune system, especially the respiratory tract. From a technological point of view, various processes taking place inside clean rooms are influenced by humidity and therefore require a precise control. For example, proliferation of biological contaminants, the speed of chemical reactions, the risk of electrostatic discharges, swings in the properties of photoresist, and increase in capillary forces. Changes in humidity due to the air circulation, like door opening, exhaust air extraction, or changes in outside and humidity content, can be prevented with a fine regulation and fast response humidification systems, like steam humidifiers with resistive elements, ultrasonic humidifiers, or high pressure atomizers.
That's a very good point. Thank you, Luca. And coming to my last question, is it possible to reach sustainability goals while improving humidity regulation?
Yes, humidity regulation is generally regarded as an energy-intensive process in the industry, and at a first glance, it could appear in contrast with sustainability goals, energy efficiency targets, and good manufacturing practices. But let's take as example an aseptic plant with dozens of clean rooms from grade A to D. A considerable amount of energy, up to 80%, is used for heating and ventilating systems, and a big part of it could be accounted to steam humidification. Many existing plants rely on plant steam lines and use clean steam generators, basically steam-steam heat exchangers, to generate pure and aseptic steam for humidification process. Other systems use isothermal humidifiers that produce steam locally and feed it directly to air handling units, avoiding energy losses over distribution lines and steam heat exchangers. But there is another option. A third option for humidification consists in using adiabatic humidifiers spraying atomized water coming from reverse osmosis systems. Atomized water evaporates in the air in short distances while absorbing heat from the air itself. This is called evaporative cooling and must be balanced by additional heat before humidification. When this additional heat is provided by waste process heat or heat pumps, the maximum efficiency of the humidification process is reached.
That is very interesting. Luca, thank you very much for making the time to join me today and giving us your insight on HVAC and temperature monitoring solutions. We're very excited to have you to join the summit, and we will be really looking forward to hear Carol's case study in Berlin. I would also like to use this opportunity to invite everyone to the European Summit on Energy Efficiency for the life science industry. That's going to be on the 3rd and the 4th of November in Berlin, to hear Carol's insight and many other exciting discussions.